Please welcome Rob and Simeone.
Thank you.
Simon.
Beth? Is it working?
Yes, I think we're all good to go.
Okay.
Hello, welcome, thank you for coming. My name is Simeon Vincent. I'm a developer relations engineer working on Firefox add-ons.
Oh.
Who are you?
I'm Rob Wool. I'm working on the WebExtensions team at Firefox on the extension APIs that can be used to build extensions.
Today we're going to be talking a bit about building cross-browser extensions in 2024, Manifest v3, cross-browser web extensions, all that good stuff. So, in case you're somehow not familiar with extensions, they're personally one of my favorite aspects of the web platform. Web extensions are little programs, essentially, that allow you to customize how the browser looks and feels. A couple of examples. Tree-style tabs will add a tree of pages as you browse the web on the left side, or I guess in the sidebar. uBlock Origin probably needs no introduction with this crowd. So it is a content blocker, or a content blocker that allows you to block pieces of functionality on web pages. And Dark Reader, as a kind of contrast to some of these other things, allows you to have your preferences, like if you prefer using dark mode, Dark Reader will enable that on websites, even if the websites don't support, or the website author didn't create a dark theme for your ideal website. Web extensions are a cross-browser extension model originally developed by Chrome, and now all browsers are aligning around this particular approach to designing extensions. Over the years, there have been a bunch of different ways that browsers have tried to provide ways of customizing or personalizing the browser experience. And the web extension model is particularly interesting because it is built using web technologies. It's built on top of the web platform itself. When you customize your browser using a web extension, the author was using HTML, JavaScript, and CSS to build that experience. Web extensions as a cross-browser thing originally started with Firefox building a new extension platform based on Chromiums. And since then, Safari has adopted it, and it's before Edge adopted Chromium as its base, they also adopted the web extension model. So this is, while it's not like a standard in the W3C or other standard group, it is a cross-browser effort. All of us are working together in the web extension community group in the W3C. And in addition to browsers, the community is also involved, providing feedback and helping evolve and enhance the extension platform. So today, we're going to take a closer look at how to build some extensions with a mindset towards maximum compatibility with current browsers, with new form factors like Firefox for Android. You're now able to have your web extensions available on your mobile phone, and how to kind of maximize compatibility as you build out a new browser extension.
Okay, so as the first demonstration, we are going to show how to modify a website. That's a very common task. Most extensions that are just starting out want to enhance a website in some way. So this is a very simple extension. This consists of two files, a manifest.json file that declares some metadata such as a name and a version of the extension, not very important for the rest of this talk. Something about the manifest version, which will become more significant as we see later, and a content script entry that declares which file should run and where. In this case, it declares to run on every site. The exact demo doesn't really matter. In this case, we are just going to register a click handler on the document that shows a dialog when you click it. And now we're going to try a live demo. And so first, can you connect your Android phone?
Oh, yes.
Okay, while he's connecting his Android phone, I'm going to type the comment. So there's a WebEx tool that is well, a program that allows you to run or build extensions very easily. It takes care of looking up the location of the browser binaries and packaging the extension and launching it without effort. So WebEx run is the command to run the extension in the current directory. T is target. In this case, we are starting at Firefox Android. And then let's see, does it do anything? Okay, so yeah, I'll show that later. Okay, well, while I'm at it, I'm just starting screen copy in the background. So this is a Firefox for Android, currently showing something. When I ran the comment before, it showed that well, some parameters were missing. In this case, we need to select which device is being used. And then it still doesn't work, because on Firefox for Android, on the Android device, there are multiple Firefox for Android applications. The IDs are listed here for convenience. In this case, I'm going to select Nightly. So the Phoenix is the code name for Nightly, and Firefox stands for the release version. There are more things such as beta and even non-Firefox builds. Okay, I launch it. There's a request to install the extension. I click somewhere, and I get a dialog, as expected. So now now I'm going to repeat the same for desktop, just to see how easy it is. I could type Firefox Desktop. By default, it launches Firefox Desktop, because initially that is the goal of WebEx. Later we expanded it to other browsers. Well, example.com. Typos. It works again. And for completeness, also Chromium. Example.com. And it works. Did I load the menu at this point?
Yes.
Okay. I'm going to back to the slide for a bit. Okay. And now to the demo. So, as you can see from the extension management page, well, it's also possible to load it manually. Just for the sake of demonstration, I'm going to remove all extensions that were installed by the tool.
Can you speak up a bit more?
Oh, okay. Sorry about that. I'm going to manually load extension. That was the original one we loaded, manifest.json. All files are there. And notice that there's some error.
Could you increase the size? I'll just pop in.
Sure. Go ahead, explain this part then.
So at the moment, Chrome has formally dropped support for Manifest v2, or that's not quite. It's deprecated support for Manifest v2. So it's no longer possible to publish a new extension in the Chrome Web Store using Manifest v2. And in fact, it's been about a year since it was supported. So over the course of the remainder of this talk, we're going to be focusing specifically on Manifest v3, because if you're building a new extension, you have to use it.
Mm-hmm. And as you clearly see, this Chrome, it can still load Manifest v2 extensions. In half of this year, they will start with experimenting to turn off Manifest v2 support, at which point it's not possible to load Manifest v2 extension in Chrome any longer. Firefox still continues to support Manifest v2. It hasn't deprecated Manifest v2 yet, so you can just load extension Firefox just fine.
I think it's also worth noting that Firefox does not yet have a deprecation timeline for Manifest v2 either, yes. Whereas Chrome has a kind of end-of-life timeline formally announced and is coming in the next 6 months.
Right. So the way to fix this would be to, well, switch to Manifest v3. The question is how to do that. So like you see, there's an error here. There was the original code that we started with. Manifest v2 was mentioned there. We bump it to Manifest v3, and then we try again. Just for the sake, since I've opened it anyway, I'm loading Manifest v3 extension. Okay, this was a manifest feature 2 one. I'm removing it since I don't care about it. This manifest feature 3. Okay, that was the old example. The new one.
Yeah, it still works.
Again. If I view this page, there's still some errors here. I'll get to that later.
Yeah.
The next part of the extension model that is very important are host permissions. In a previous example, we ran the extension on all websites. We requested to do so on all websites. And we bumped the extension to manage v3, and it still worked in Chrome. What I didn't show yet is how to run extension on Firefox. Well, I did show how to, but not that I did so. So let's try again.
As Rob builds this up, one of the notable differences between in Firefox's support for Manifest v3 is host permissions are limited by default. We want to encourage developers to go in the direction of giving users more control over where and when extensions run. So by default, the set of hosts that the extension declares aren't
Granted by default.
Thank you.
So at install time, Manifest v3 extensions do not get the permissions, unlike Chrome. That's a common source of confusion for extension developers. And as you just saw, I launched Firefox again with the Manifest v3 extension. You click around, nothing happens. What you do see is that there is built-in extension UI in Firefox to control permissions. So if you enable the permission from this point and load it again, it will work. So that is the built-in UI in Firefox. Chrome has similar UI to disable it. So even if you currently think that your extension works in Chrome, it may not if, for example, the user has disabled it, or maybe sometime in the far future, Chrome has also followed a similar approach. It's also worth noting, even though we only show Firefox and Chrome here in today's presentation, that Safari has also something special for host permissions. In fact, all host permissions are disabled by default. Safari takes the most strictest approach to host permissions for privacy reasons, meaning that you have to explicitly interact with the browser UI to allow the extension to run on the page. In a previous slide, I showed the built-in browser UI to do so. Now I'm going to show how to do it in your own extension with the right context to get the user to convince the user to give you those permissions. To do so, in the manifest file, declare the options UI page. In this very simple extract of the options page, I show a label. This is just a very simple explanation. In reality, you may convince the user that they will win something. That they will get some useful functionality. Please do not mislead the user. And there's, for the sake of this example, a checkbox to grant the permissions. For the demonstration, I'll be very to the point. Checking the checkbox will give access to example.com. In your own extension, you may use a more descriptive, non-technical description. And finally, I load the options.js file. In options.js file, I declare the permission that I want to request. The permission follows the format as shown on the screen. The origins key of the object declares a list of match patterns, which you saw before in the manifest file. The match patterns are the common way in extensions to define on which host an extension operates. In this case, in this context, with permissions, the path is ignored. Because when you request access to example.com, it doesn't really matter whether it's example.com/favicon or example.com/index.
It's also worth noting the scheme in this case. The wildcards are a little special in the way that they work. They're not, general glob patterns. Scheme, the asterisk here, specifically means HTTP and HTTPS. It doesn't include filed URLs. And the asterisk in the domain or in the host section, it can only be a prefix. It can't pattern match on the top level domain or in the middle of a pattern. So it can only specify subdomains. Right. And in this case, asterisk dot includes both subdomains and example.com.
Thank you. Okay. So the UI was very simple. We had a checkbox and a label that you can click that triggers the checkbox. To start with, we will first make sure that the checkbox reflects the actual state of the permissions that you have. So you check the permissions that you have and update the checkbox state. Very useful. Now you need to make sure that when the checkbox is ticked, that the permissions are actually granted. To do so, we introduce a change listener. The change listener is fired when the checkbox state changes. When the checkbox itself is checked, so that means that the user checked the checkbox, we want to make sure that the permissions are granted if they have not been granted yet. So we use the permissions.request API to do so. And if somehow the user dismisses the the permission request, we uncheck the checkbox to make sure that the UI is consistent with what actually happened. To remove the permission, we do something similar. You'll notice that in this case I'm using try catch because Chrome has something special about it, which we'll explain a few minutes later. And finally, also note that I use permissions.onAdded and permission.onRemoved event listeners here. These are triggered when the permission change, not just by the checkbox here, but also if you use built-in browser UI or simply have opened the tab in a different page. It's a very common mistake of extension developers to not account for changes in other tabs or other external factors. So make sure that if you have some UI or settings page, synchronize it with your other potential external triggers. I am going to demonstrate it. Just a bonus tip. So in the demo here, clearly you can see that the browser is using dark theme. By default, a web page and extension page included use a light theme. With just one simple trick, adding a meta name color scheme with content dark and light, you can automatically get the dark theme support for your extension page. Even if you don't develop any extensions, take away this tip for your own web applications. With very little effort, you can get dark theme support automatically without the need for extensions.
I actually learned about this from Rob earlier today.
Right, so if you click on the checkbox, you'll see that permission request comes up, and then you can choose to allow or disallow. Were you going to continue?
Did you also want to show it on Android?
Yes, thank you. So on Android, the flow is also similar. You find the settings page, as you can see through these arrows, and then you can also grant the permission to the similar UI. I could do a live demo, but just for the sake of time, I'm just going through the screenshots. If people are following this later, the slides are also published later with screenshot included, so you don't have to watch the whole video recording. So this is the Chrome UI interaction.
Yep,
Demo?
it is.
Okay, that was the special part about Chrome that I'm going to show now. So previously I said there was some try-catch to handle some error in Chrome. The reason for that is...
I'm sorry. I
What
accidentally navigated. I just wanted to make it bigger.
Okay, yeah, it's bigger. Thank you. If you click here, you'll see that, nothing happens for some strange reason. The reason for that is that in Firefox you can always, the user can always toggle permission, and an extension can do the same. In Chrome, an error occurs when you try to remove a permission that is declared in content scripts, because the extension claims that it's a required permission and Chrome refuses to remove it. You can still trigger the same flow by using the site access control that I mentioned before. So this is the built-in UI from Chrome to control access. There are several ways, including on-click. So now I try again, and I see the checkbox is unchecked. I can check it, permission request appears, approve it. Okay, now I'm locked in the jail.
But the important thing there is, again, permissions can be revoked outside of your extension's flow, and you might not otherwise have signals to it. So it is critical to subscribe to those events and make sure that you're reacting to them appropriately. Right, so in this example that we looked at so far, we've statically declared our content scripts and had them automatically run on the page and then respond to the invocation on click. But if we really want to embrace user control, user privacy, it is best to react to a user's invocation of the extension and then perform the work that you need to do, rather than always statically injecting and potentially having access to sensitive information that you don't actually want. So both as a user, you're protecting your own data. As a developer, you're respecting the user and making sure you don't have access to content you don't need. So the pattern that we want to encourage is that kind of in-context reaction. And we do that through a special permission called active tab. So in this demo, we're going to be using the active tab permission to detect when we're invoked and then get temporary access to the page. And then we're going to be using the scripting permission to execute the script in context. And we're going to be doing that using the extension's action icon, the thing that appears in the toolbar that identifies your extension. It's also worth noting that declaring action in this file is necessary. If you don't, you can't actually use that API. So it's kind of an implicit permission. In this demo, we're going to be targeting specifically Firefox. So we're going to start with a scripts array. This is kind of the more traditional approach. It uses a background page, an event page, in order to run the script. We are going to be targeting Chrome in just a little bit, so we're going to kind of ahead of time polyfill the browser namespace. The Chrome version of the extension platform uses the global Chrome, and Firefox, when it implemented the web extension APIs, it used the namespace browser. And the big difference between the two is that browser supports promises, and Chrome historically did not. It does in Manifest v3, but so we're using this quick polyfill. If you are targeting Manifest v2, you'll need a larger, more extensive polyfill. And so as described, when the user clicks the action, we will execute a script, we will inject on the current tab, and we're just going to alert. We're going to skip over that for time.
Skip the demo.
Yeah, skip the demo. You get the idea, it works. So when we target Chrome, we're going to actually need to use a different entry point into the background context. We previously used scripts. That's what was used with pages. Chrome no longer supports background pages. It only supports a service worker. So we need to declare a different entry point. Again, you believe me that it works. The important thing now is we have two different entry points. And ideally, as an extension developer, you don't want to deal with having a bunch of different files and special configuration per browser. So in very recent versions of Chrome and Firefox, it's possible to declare both scripts and service worker in the same manifest file. But because this is so recent, we don't want users with older versions of Firefox or Chrome to get these updates without, and have the extension fail to load and run. So we're going to add some guards to our manifest here. We have, for Firefox, we have the Gecko and Gecko Android keys, and the strict min version, it just coincidentally in both browsers is version 121. There's no association beyond that. And critically in Firefox, the ID field is required when uploading a Manifest v3 extension to AMO. And then in Chrome, we target, again, 121. And that all works as expected. Wonderful. Over here, I want to highlight that scripts is an array. So it's possible to declare multiple files. And so you can have libraries or chunk your application up into different pieces in order to better organize your code. Whereas service worker is a single entry point. So it's possible to achieve this multi-file loading thing with a slight tweak. In this case, we can use like a service worker JS file as your entry point. And then in that file, we're just going to use import scripts, which is special to worker contexts. It will synchronously import these scripts and execute them. So we can achieve the same result with, again, a single manifest file and a slight tweak to how we load service workers.
We're going to skip this part.
Okay.
Basically, an older way to run this, to get the same functionality without the background script. If you care about cross-browser compatibility, but without dropping support for older versions, you can get rid of the background script and use a pop-up that opens when the button is clicked and close the pop-up.
So let's talk about short-lived background context. In Manifest v3, one of the major changes to the extension platform is, in the past, we had persistent background pages, and that's no longer an option for constraints outside of the browser's control. In order to be able to run everywhere and run efficiently, we necessarily limit when an extension, we terminate idle extensions background contexts. And that has some important consequences for how you design and build your extension.
So we're going to quickly skip towards the end because of time. We have prepared like for over an hour, I guess, of presentation. So if this kind of interests you, you can look up the slides from the FOSDEM link. The speaker notes are also included. We don't see them here, but we make sure that the slides are understandable even without video. So.
Yes. It's also, I think, worth noting, we're planning to expand on this and do like a webinar later to share some of this content and explore it with less time constraint. So hopefully we'll see you tuning into one of those sessions and answer some questions from you all about building browser extensions.